Anyway, so as I was saying, Fred's books, my personal favourite is Stargazer, which is an excellent work on the the evolution, if you like, of the telescope. And Fred's music. Fred writes some. In fact, Fred is the only person I know who writes astronomical music, which is really fantastic. And I still listen to your CD in the car every now and then, Fred. So I recommend purchasing Fred's CD if you get the opportunity. And of course, Fred has a number of other outreach activities. Venturing across the globe, taking people on astronomical tours, and so on. Fred also holds adjunct professorships in several Australian universities and was made a member of the Order of Australia in 2010. And Fred has an asteroid named after him, 5691 Fred Watson. But Fred says that if it hits the Earth, it's not his fault. So anyway, would you please, you've got a little down the bottom there somewhere. It's a while. Oh, you've got a little reactions. So you can either give Fred a clap or a thumbs up. So welcome, Fred. I'm going to, like I said, find the mute button here somewhere. But if you can mute yourselves so that we don't get a lot of noise in on the talk. So please welcome Fred first.
Hi, Thank you, Fred. Paul.
And
I do feel welcome.
Yeah. Thanks, Fred. And to introduce the subject of Mars, I'm going to make comment about my first exposure to Mars was as a child. And growing up in Adelaide, we had a character called Deadly Ernest. And Deadly Ernest used to host late night science fiction and horror movies. We had a lot, came out of the writings of H.G. Wells. There were different Mars invasion movies made in the 1950s. And in particular, I remember a movie called Invaders from Mars that was made in 1953. And it was basically, cutting a long story short, about a ship that landed and buried itself in the sand. And it was witnessed by a child. And he was trying to convince everyone that these Martians had landed. And everyone that went up onto this hill to investigate got sucked underneath the ground into their spaceship. And then, of course, when they came back, they'd been altered in some way by the Martians. And as a child, that was quite terrifying, even though I used to like sitting up and watching that. So that was my first really exposure to learning anything about Mars. It was through science fiction. So I'm going to throw it over to Fred. And Fred, what was your first impressions? What did you first hear about the red planet?
So pretty well as you did, Paul, only a lot earlier, because I'm 100 years older than you. But in the 50s, when I was growing up...
Now, Fred, can I just stop you 1 second? I'm just going to mute everyone, and then I might have to unmute you. Sorry, Fred. I'm just trying to unmute you.
Do you think I'm unmuted now?
Yeah, go for it. Yep.
Okay. So when I was at school in the 50s, there was a comic which was called The Eagle. And it's on its front page was the space hero, Dan Dare. And Dan Dare was the pilot of the future. He actually went all over the universe, as it turned out, doing good things because he was a good guy. But he certainly had things to do on and around the planet Mars. And that, I guess, is where the interest started in terms of that particular planet. Although I have to say, Paul, that when I was growing up, space science and astronomy were really in the ascendancy. They were what everybody was fascinated by. And of course, the education system at the time encouraged kids in particular to be fascinated by this kind of thing and science in general, because they all thought another world war was coming quite quickly. And they wanted people who had been educated in science in order to try and fight that. And so what happened was we were all mad keen on space, Dan Dare, the whole lot. And then my colleagues at school all went off and they were all educated in science, but they became architects and engineers and dentists and doctors and sensible things like that. And I just never grew up. I have a question for you, Paul.
Yes, absolutely.
Is the laterally reversed headline that you've got behind you intentional?
Is it the wrong way around, is it?
It is. It's the
Oh,
mirror image.
well,
Yeah,
the
it
funny
looks.
thing was I put it up my end and it was reversed. So then I had to reverse it again. But I've got a version here somewhere that is probably the right way round, Fred.
Don't
Let me
worry
have a
about it. It's okay. We can all read it. It says "Zram Noise van in." That's what it says.
That's right. So yeah, so in a way, your first exposure to Mars was kind of through science fiction
Yes, it was. Yeah,
as well.
yeah.
And one of the early pioneers that brought a lot of this on was, of course, as many people will know, the Italian astronomer Schiaparelli, who was one of the earliest people to study Mars in detail and reported things like canali, which was promptly translated into channels. Do you want to comment on that, Fred?
Indeed, yeah. I think was it 1877? I was reading some notes I wrote a couple of months ago about Potted Guide to Mars. It was because Phobos and Deimos, the two moons of Mars, were discovered in 1877, as was the map of Mars made, as you said, by Giovanni Schiaparelli. He made a map which showed what he described as canali, the Italian word for channels. And as you were about to say, before I rudely interrupted you, the English media, the English-speaking media got hold of that as canals. And indeed, the maps that were drawn around about then show a network of what looked like canals on Mars. And the other thing that I guess persuaded people like Schiaparelli and his disciple Percival Lowell, who founded the Lowell Observatory in America, it was the fact that Mars does change its appearance seasonally. And everybody put that down to being due to vegetation. I have actually, it's a book that was written in 1961. You won't remember it, but every year until, in fact, the year of his death, and I think they still go along, Patrick Moore produced a Yearbook of Astronomy. The first edition was the 1962 edition. So he wrote that in 1961. And what he wrote was that it's generally accepted that Mars must have vegetation because of the seasonal changes that we see. That was, not that long ago.
That's right. I mean,
yeah.
Patrick Moore was one of my early inspirations. I remember when I first started astronomy in Adelaide with Michael O'Leary, who ran astronomy courses for many years. And Patrick Moore was at the top of his game. As many of you will know, he ran The Sky at Night, one of the longest running television shows in history. And at the time, I bought two books. One of them was by Ian Ridpath and Will Tyrion, and that was Collin's Guide to the Stars and Planets. The other one was the Guinness Book of Astronomy, which was written by Patrick Moore. And one of the things I always remember in that particular book was a chapter on Mars, and in particular that stuck in my head was the size of Olympus Mons, the highest known volcano in the solar system. And to think about this, a mountain being, nearly 3 times the height of Mount Everest is just amazing. So, there are these amazing topographical features on Mars. And of course, this is all leading up to eventually putting people on Mars. And as you mentioned, Percival Lowell was fascinated with Mars. And in fact, I had the opportunity to go up to Mars Hill in Flagstaff, Arizona, where his observatory sits. And he's actually buried right next to his observatory. So it's a fantastic place to visit. And as you mentioned, Asaph Hall, who discovered Phobos and Deimos in 1877, the same year that Schiaparelli drew charts on Mars and these canals and so forth. And from a mythological point of view, I should probably mention Mars, of course, is named after the Roman god of war. The Greeks called him Ares. And Phobos and Deimos are characters. They were attendants, which basically mean fear and terror as well. So there are strong mythological connections, if you like, with the red planet Mars. And the Babylonians called Mars Nergal after their archer god of war. And the Mangala was the Hindu name, who was born from the sweat of Shiva in their culture. And Ma'adim was what they called, the Hebrews called Mars, which meant one who blushes. And if you haven't figured out, ethnoastronomy is kind of my field of expertise for people having a bit of a listen as well. Fred, from a historical point of view, how big a role do you think, Herbert George Wells wrote War of the Worlds in 1898. They've sort of given people this perception that we're going to be invaded by Mars. And when, I think it was Mariner 4, please correct me if I'm wrong, first photographed the surface of Mars in 1965, a lot of people were disappointed when they just saw craters and it appeared a lot like the moon. Could you comment on that, Fred?
Yeah, I remember that very clearly because, the Mariner projects were in the mid-60s. I think you're right, it was Mariner 4 and maybe Mariner 5 as well. Only 4 years before that, Patrick had been writing, yes, there must be vegetation on Mars. And we were then suddenly confronted with this alien landscape resembling the moon more than the Earth. So I remember seeing the pictures of the craters on Mars when those images came back, and it kind of reset the whole paradigm in which people thought about Mars. And the other thing is that these spacecraft also were able to make measurements of the atmosphere and things of that sort, and it became very quickly apparent that Mars has an atmosphere that's too thin really to support anything like vegetable life, a pressure less than 1% of our atmospheric pressure here on Earth. So it was an entire change of our view of the planet. But of course, what it did was only increase people's curiosity about Mars. And so the next big step were the two Viking Landers in 1976 and the associated orbiters. They were really the huge step forward in our understanding of what Mars is like as a planet, compared with what we thought of, only a decade and a half before.
That's right, and as you said, the Viking 1 and 2 in July and September of 1976 were inspirational in looking at Mars and the surface of Mars. And probably, to be fair, we should mention the Soviets as well, which landed a probe in 1971, but it failed about 30 seconds or so after landing, so it was never deemed successful. And it's
Mars
interesting.
3.
Pardon?
Mars 3.
Yes, that's right. And it's interesting that the Russians were so successful in sending space probes to Venus, but not Mars, where the Americans were very successful in sending space probes to Mars, but not so much Venus and some of the other worlds. You mentioned about one of the things we're all wondering about is everywhere we look on the Earth, we find life. We find extremophiles living in highly acidic environments, high temperatures, radioactive environments. And one of the hopes, of course, in the early days would be that we're going to find intelligent life on Mars. I'm still looking for intelligent life on the Earth personally, but what are you
surrounded by it, Paul? By all these
well,
people
everyone here certainly here, present company accepted. But certainly, what do you think are the odds of finding microbial life, or keeping in mind the fact that Mars had running water at some stage in the past, either possibly fossilized life? What are your thoughts on that, Fred?
50-50. So the paradigm that we've built up as far as Mars is concerned, and it comes from, you might even be able to put up a relief map of Mars, Paul, if you've got one to hand.
I've got the poles, I think, here somewhere.
Yeah. The point is, you don't need to be any kind of sleuth or detective or scientist in order to recognize that Mars is a two-part world. The northern hemisphere is low-lying, flat, almost completely devoid of craters, whereas the southern hemisphere of Mars is mountainous, lots and lots of craters, has around the equatorial region that area called the Tarsis Rise, which has the 4 large volcanoes on it, including, as you mentioned already, the biggest volcano in the solar system, biggest mountain in the solar system, Olympus Mons. But the planet does divide into 2 halves. And so the thinking very much has been, here we go,
Can we see that? Can we?
that the, yeah, I wonder if I can share my screen, because I've got one that shows exactly what I'm talking about here.
Yeah, I can bring up the volcanoes that we were just talking about as well.
Okay. All right. Yeah.
If you keep chatting, I'll.
Yeah. No worries. No, it's the relief on Mars is very much divided into 2 halves, and so the thinking has been, and with good reason as well, that Mars at some stage had either a sea or a series of seas or an ocean in its northern hemisphere that essentially revealed, that caused that different topography from what we have in the south. The thinking is that this occurred maybe 3.8 to 4 billion years ago. So very early in Mars's history. Mars is 4.6 billion years old, the same as the rest of the solar system. The idea that Mars was warm and wet, which seems to be borne out by the geomorphological evidence. You can see coastal features around this low-lying area. You can see signs of ancient beaches, ancient sea stacks, sea cliffs. That has made people assume that Mars was a warm, wet world. But that's actually been challenged recently, Paul. I don't know whether you've seen that work that came out of the University of British Columbia. It's about a month ago, and the work that they've done actually tallies more with what we understand about the atmospheric evolution of the planet Mars, the way the atmosphere itself has evolved. It's difficult to find a mechanism by which Mars would be warm and wet. And by that I mean having a temperature like, an average temperature like the Earth of 15 degrees Celsius. And so the University of British Columbia's work is suggesting that actually what we had was a Mars that was still cold, covered in large ice sheets, perhaps an ice sheet covering that whole northern hemisphere, but with drainage channels underneath the ice. And the reason that they have come to this conclusion is that they are very familiar with drainage channels underneath ice sheets in northern Canada, a place, if I remember rightly, called Devon Island, that they've studied. And the ice sheet actually presses down, so you get pressure, you get the freezing point of water lowered. There are probably perchlorates, which are like a natural antifreeze in Mars's, in the water of Mars, in the ice of Mars. And so the suggestion now is that these channels may have been, for some of the river channels, which we see, may have been formed underneath ice sheets rather than in open water, because open water would be in balance with the atmosphere of Mars. Just to kind of tie up the loose end there, we know that this was water on Mars because a lot of it's still there in the form of ice. You're looking now at the south polar cap of Mars, which is, some of it is solid carbon dioxide, but most of it's water ice. And if you froze what you can see, if you thawed out what you can see there, it would flood the entire planet to an average depth of 11 meters. It's very misleading, that little blob of ice. There's a lot of ice there. And one other thing that we know about that is that deep down under that ice, there is a liquid water lake, something like 40 kilometers long. So that's the thinking that leads people to the idea that there is a good likelihood that Mars at one stage harbored life. Wherever we find water on Earth, we find life. It's the working fluid of all life on Earth. And so that's why I think people put the odds of us finding either signs of past microbial life or even present microbial life on Mars as being reasonably high. It's why I would have said 50-50. Sorry, a long answer to a short question, Paul.
No, very good answer. And one of when you talk, I'll look for it. I've got a slide here. One of the things with Mars having such large volcanic features, and there are around 20 named large volcanoes on the surface of Mars and many smaller ones, is around some of them there seems to be caves. And so the suggestion has been that because of there's no ozone layer to protect life from ultraviolet radiation and so forth, that life could exist underneath rocks or possibly in these caves, these lava tubes and so on. What are your thoughts on that, Fred?
So you broke up just as you were asking the question there, Paul. Do you want to just repeat the very last bit of your question?
So I guess
might be under rocks or somewhere else.
Yeah, I'm guessing what I'm asking is the Mars Global Surveyor and some of the spacecraft have photographed what appear to be lava tubes or caves on the surface of Mars.
Yes.
And the
yes,
suggestion
okay.
has been made that life could live in these vents, and possibly even future colonies could shelter in these vents as well. What are your thoughts on those?
Well, my thoughts on future colonies are not terribly enthusiastic, but we might get to that in a few minutes.
Yeah.
Certainly, as far as living organisms are concerned, you're quite right. Yes, we know of things like lava tubes, certainly tube-like structures on Mars. That they might be the kinds of places where microbial life still exists. We haven't talked about the methane plumes on Mars because Mars is well recognized as being a world that has an atmosphere that occasionally has excesses of methane in it. And methane is something that doesn't hang around long. It's dissociated by sunlight into its chemical components and doesn't stay a molecule for all that long. So if you've got methane on Mars, and there is indeed methane on Mars, then it must be being replenished somehow. How is that? The two main theories for what might be causing that are residual tectonic activity, volcanic activity, that may be still seeping methane out from, for example, beneath the Tarsis Rise, where Olympus Mons is. That might be leaking out methane, or it could be methanogenic bacteria, because many bacteria on Earth anyway, are methanogenic. So that's a very exciting thing. It's also tantalizing because Curiosity, which certainly detected methane spikes. Curiosity is a rover on the surface of Mars. It was sent to determine whether Mars was ever habitable, and it found that out within about 2 weeks of being there by finding mudstones and things of that sort, which speak of there having been a liquid surface. Martian caves, good stuff. The methane spikes that Curiosity detected have not been able to be linked with similar observations made by the Trace Gas Orbiter, which is a European Space Agency orbiter. It's looking for trace gas, namely methane, in the upper atmosphere of Mars, and it hasn't really done very much in the 3 or 4 years that it's been there. So hiding under the surface is likely to be where any extant Mars life might be. It's where it might have been in the olden days, when perhaps there was more life on Mars than there is now. Just one footnote, though, to what I was saying earlier about the ice sheets perhaps covering Mars and drainage channels underneath them being the waterways. Those scientists in British Columbia have been very encouraged by that, because they think microbial life would survive better underneath an ice sheet than it would on a watery open surface, because Mars doesn't have a magnetic field in order to protect it from the radiation that the sun throws at us all the time.
Fred, do you think with the role of orbiting spacecraft now and eventually sending humans to Mars, and there's a goal to have them there in the early 2030s and back to the moon, if you're to believe people like Trump, in 2024, do you think radio astronomy can play a role in the exploration of Mars? Now with the Australian Square Kilometre Pathfinder and the SKA Square Kilometre Array and so on, do you think there's a way that radio astronomy can teach us more about the red planet?
It's a great question, and certainly one of the one of the science goals of the Square Kilometre Array, which is a giant array, two giant arrays actually, one in the High Karoo in South Africa for the mid-frequency wave band, and one in Western Australia, 350 kilometres from Geraldton for the low-frequency wave band. One of the science goals is astrobiology. It's to look for evidence of life beyond the Earth. The array is actually sensitive enough. This is a statistic I absolutely love. It's sensitive enough to detect an airport radar at 50 light years. Wow. So, if there's airport radar within 50 light years and SKA is pointing in the right direction electronically, points, maybe we'll find evidence of a civilization. My guess is that's not going to happen. The other kind of thing that the SKA can look for, though, is signs of life in an atmosphere. It's sensitive to things like the transitions that you get when amino acids are excited. Now, in a planetary atmosphere, that might not be the same as being in the environment of a young star, which is likely to be the kinds of places that the SKA will look for in terms of the search for life. But you never know, and you can bet your boots that the SKA will have a shot at Mars probably fairly early on in its history. Might only be a calibration, but I bet it does.
Yeah, and of course, a lot of people probably don't. That's fine. A lot of people probably don't realise that one area that Australia's always punched above its weight is in radio astronomy. We've been world leaders in that field for many years as well.
That's right. So after the Second World War, when radio astronomy started to be recognised as a big future part of the study of the heavens, the leading nations were the UK, the Netherlands, and Australia, and all those countries were great at turning old wartime radar equipment into the kind of detectors that you need, the receivers that you need for radio astronomy. And I guess the Parkes dish was the iconic radio telescope. There were many experiments done both in Canberra and here in Sydney in the early days of radio astronomy. But in 1961, when the 64-metre dish at Parkes came on stream, that was really when radio astronomy became recognised as one of Australia's great strengths. In no small measure due to its part in relaying signals from the Apollo 11 spacecraft, along with Tidbinbilla as well, or Honeysuckle Creek as it was then.
Creek, of course, yeah. Fred, I think it's exciting to live in an age where, strictly speaking, we've only been flying for just over 100 years, and we're already looking at the surface of other worlds. The Chinese landed a probe on the far side of the moon. The first time we had a really good look at the surface of the far side of the moon. Yeah. We've seen a number of different sites now on the surface of the red planet. And most recently, the Perseverance and Ingenuity drone or helicopter has been launched. And I find that exciting because for a long while, I've been thinking, like, why don't they put a helicopter or something on Mars so we can fly over and take images? And I guess this is a technology demonstrator, really. Yeah. But it's going to be very exciting. And just can everyone see that picture I've got on? Can you see that picture, Fred?
Yes.
Yep. Yep. So I think it's exciting that you've got something very similar to the Curiosity rover and so forth. And this little drone helicopter is going to drop out the bottom and fly around. And I believe it's got a small camera. It's going to take some images as well. I think, what are your thoughts on this and where we're going with this?
Oh, it's fantastic. It's it's the kind of thing we dreamt of when we were being swallowed up by our respective science fiction stories back in the dark ages. The idea, first of all, of a helicopter on Mars is an astonishing one. It's a small craft. Its rotors, there are two rotors exactly as you can see there with a solar panel on top. The rotors rotate in opposite directions. They're just over 1 meter long, each one. That gives you an idea of the scale of it. If I remember rightly, the whole thing weighs, I think it's about 4 kilograms. It's pretty hefty.
Very light, yeah.
And the the extraordinary thing is that here you are on a world with an atmospheric pressure of about, well, less than 1% of that on Earth. What are these wings going to bite on?
Yeah, exactly.
They have to rotate very quickly. Once again, 2,500 RPM or thereabouts comes to my mind. It's something really fast like that, much faster than a drone that you would expect to see on Earth with wings that size. Of course, in your favour is the fact that Mars only has a third of the gravity of the Earth, so you're not working against quite as much downward pull. You're right; it has a camera on board, but no other scientific instruments, and I think that's exactly as you said. It's a technology demonstrator, but it's going to give the operators of Perseverance. It's going to give them a big advantage over the operators of Curiosity, because you know what the terrain of Mars is like. It is not a smooth world, even though that sketch probably looks like the bottom of Jezreel Crater or something. It's not like that, especially the bits that they want to explore, because these are the bits where all the good geology is. And so the ability to look over the next ridge and see what exactly the terrain is like, to check out what big boulders might get in the way of Perseverance, all of that is going to be a big advantage for the mission operators. But the other thing you have to remember, of course, is that this helicopter is operating pretty well autonomously, because the travel time for the signals between Earth and the helicopter and back again it's far too long for the helicopter to be able to react. So there'll be a lot of AI in it, and let's all hope that that doesn't all go wrong on day one, and we find bits of smashed up helicopter on the ground. But
they've done amazingly well. The Americans in particular, I know there were problems when they sent the Beagle probe or Beagle 2 probe there and so forth, even though the orbiter's been quite successful. And I think I read, Fred, that when you were talking about how thin the atmosphere is, to experience the same kind of atmosphere on the Earth, you'd have to climb to about 32 kilometres above the surface of the Earth. You know, that's how thin the actual atmosphere is. Again, you know, this is leading up to eventually putting people on the surface of Mars. And I think there are a lot of challenges with putting people on Mars, as far as, you know, having spacesuits. You know, how would the dust affect their suits? I know with the lunar regolith, you know, some of those particles were quite sharp, and, you know, the argument's been made that if you breathe them in, you know, they could damage your lungs and so forth. And that's not to mention, you know, having the fuel, having the food to eat, all of those things, I think, are quite a large undertaking to do over time. And you kind of indicated you weren't as confident maybe in human migration to Mars in the future. And one of the, I think, arguments Carl Sagan made many years ago was, he said, because of the way we've evolved on the Earth, we've really evolved to, you know, to live on the Earth, and we're not well adapted to living in space. And he was an advocate of sending robotic spacecraft out as opposed to as many human missions. He didn't say we should stop them. But what's your opinion on that? Do you think we're far better letting drones and autonomous spacecraft explore other worlds, or you think there should be a human, partly human involvement in that as well?
Yeah, so I think there's a place for both, because you know, Carl Sagan was right, and you've only to look at NASA's activities and other space agencies' activities in the last 40, 50 years to see how successful that's been. Think of Cassini, think of New Horizons, think of Juno around Jupiter now. Extraordinary stuff that has been achieved by robotic exploration. But there is nothing quite like humans walking on other worlds. That's what inspires us. It's what grabs people by the scruff of their necks and makes them think this is an astonishing achievement that we're doing. There is a fairly gung-ho attitude among some entrepreneurs and commentators that would make you expect that we might see humans walking on Mars within the next 5 years. And not just humans, but humans in very, very large numbers. In other words, you know, mass migration to Mars. That, I think, first of all, I think it's pretty unrealistic. There are technical challenges above and beyond just building big rockets, which is actually happening. Those big rockets are already on the stocks, but there's much more to it than that. Getting people to Mars, 6-month journey at the very best of times. And you know, you're not going to be able to get back for another year after that, because you've got to wait for the orbit of Mars and the Earth to align up in the proper way in order to make the transfer between the two. These are all things with psychological issues that are not really yet fully understood. Not to mention the you know, the radiation issue, which is always going to be a problem with long distance travel to Mars. So my view of the ideal way to explore Mars is a bit like the way we explore Antarctica now, without using the idea of it being a lifeboat for the Earth, because it's certainly not that. It's for a start, most of the problems that we have on Earth can be dealt with. Some of them, you know, some of the ideas that might threaten humankind as a species, we couldn't do anything about. But those are the ones that you wouldn't do anything about if you're on Mars either, things like a nearby supernova and things of that sort. Most of the issues that we face are tractable. So the idea of colonizing Mars, which you know, I think is not a good one. I think there's ethical problems as well as everything else. But that might well take the attention of people off what we need to do to make the Earth a place which is fit for a much longer future than perhaps some of these entrepreneurs see the Earth having. I think we're in better shape on Earth, partly because of the space age, actually, and the need to have a lifeboat in space is not that urgent. Having said that, an idea that I do like, and I was delighted to find that this is supported by Jeff Bezos, who's another of the entrepreneurs with big ideas. I think we could, you know, I think there is a place to think about large-scale artificial structures in space. And I guess in the extreme view, it's things like the Halo world, which some people might be familiar with from that game, essentially a ring world, where the rotation provides the acceleration that replaces gravity. And you build things on such a scale, probably with resources mined from asteroids, which I think is a reasonably ethical thing to do, as long as you can sort out who gets the profits. That sort of thing, I think, is a more, you know, perhaps a more tractable way of seeing an off-planet future for humankind, rather than going to a place like Mars, to which we're not really suited. You can build an artificial environment in space which would suit us better than the surface of Mars, and probably would be cheaper. And don't get me started about terraforming Mars, because it doesn't work.
I think you raise something very interesting. I've always been a big fan of David Attenborough, and I've always been one of those people that one of the things I think that is never really addressed seriously is fixing the problems on the Earth, and those problems are caused through overpopulation. The bottom line is we just have too many people on the planet, and it's getting worse and worse and worse. And economists argue that we need more people to pay for older populations and so on. But you know, where does it stop? And a lot of our problems with needs for food, for water, for fuel, fossil fuels, is all a result of having too many people on the planet. And I think until we address some of those issues, having other populations on other worlds is, like you said, is not the way to solve things as well.
So Paul, this is straying into territory that I don't normally address, but let me do it, just stick my neck out. There are some very reputable economists who see what you've just described as a non-scenario, because we know from the way populations change and demography that the population of the world will peak. And certainly the best guess that I saw, this is a few years ago now, suggested a maximum population of around 10 billion in 2060, after which the population will fall. And if you do things right, 10 billion is quite sustainable on the Earth. But you have to look after the planet. You have to be good. You know, the husbandry that you bring to agriculture and things of that sort have to be totally sustainable. But it's a future that is not, in any sense, a kind of a downhill future, one that is going to bring humankind to an end. The economics work in the same way as demography works to actually stabilize things. You probably know, Paul, because we've talked before, that I'm a born optimist. So I look at the through, through rose-colored glasses. But that's the word from senior economists, and I think it's a very interesting prospect.
All right. Now, changing the topic a little bit before we'll come to some questions. There are a number of questions on the chat there, I think, as well. We did kind of touch briefly on Martian volcanism, and Mars has these amazing volcanic features, and I'm sure that they will be an absolute geological paradise for geologists when they go there.
Yes.
We're looking at, I don't know if you can see my pointer there, but the top of Olympus Mons there. And I thought I'd comment, if I can change slides here, about, and you may want to comment to this as well, Fred, about why we have such large volcanic features on Mars. And you mentioned earlier about the 1/3 gravity and how in the past when Mars was still quite warm inside, obviously had hot spots beneath the surface. And so we think that Mars hasn't had the same sort of tectonic activity as we've had on the Earth, where plates move and create things like the Hawaiian Islands and so on. And so when we've had a hot spot on somewhere like Mars, a volcano like Olympus Mons has just been able to build up after a number of different eruptions. However, as we, wrong button here. Sorry, I'm using two computers here. So as we have a hot spot on the Earth, and I use the example here with the Hawaiian Islands. We've got a hot spot, and one of the islands pops up over time, and then of course during that time, the tectonic plates are moving, and the hot spot's still there underneath, and so we'll go through these slides here, and then we end up with something like the Hawaiian Islands or the Galapagos and so on. Could you make comment about your thoughts on this kind of activity and so on?
Yeah, Paul, that's a perfect illustration of what we think the situation has been on Mars. That Mars seems to have a crust that's like an orange peel. It's continuous. It doesn't have the fractures in it that we have on Earth with the tectonic plates. It's also possibly one of the reasons why Mars's atmosphere changed. So let's just take these things one by one. You're right that because there's no plate tectonics, if you've got a hot spot in the mantle, and clearly there has been one, then what you get is the universe's biggest volcano. Maybe not the universe, but certainly the solar system's biggest, because it just keeps on erupting through the crust. It just builds up and builds up and builds up. And it's not just the Olympus Mons. There's 3 other large volcanoes close by, and they're not very well, I guess 90 degrees in longitude away. There is the Elysium Mons rise. Yes, those are the 3 other volcanoes there, the Tarsis Mountains, with I think it's Arsha Mons down at the bottom. That's the one that sprouts a cloud every solstice. It's not volcanic.
Arsha, Pavonis, and Astraeus Mons.
That's right. Yeah. So it's the lack of plate tectonics that seems to have driven these huge volcanoes. But it may well be that early in its history, Mars did have plate tectonics, because there are kind of fossilized magnetic fields that seem to lie along along these fault lines that may be the remnants of there having been tectonic activity. And I think most scientists think that if there were plate tectonics early in Mars's history, the reason why it shut down was perhaps the same reason that it doesn't have a magnetic field. There is not enough internal heat to maintain either a fluid core mixed with a solid one, as we have here on Earth, and that's an iron core, to generate magnetism, or it doesn't have the same heat to sustain plate tectonics, because plate tectonics works by thermal columns in the mantle of the Earth. We think the Earth is the only rocky planet in the solar system that has plate tectonics. Maybe Mars used to have, maybe Venus used to have too, but now it's only the Earth. And we know that plate tectonics actually has a role in stabilizing the atmosphere, in maintaining the carbon content of the atmosphere. It's an emotive topic, I know, because we talk a lot about carbon dioxide and climate change. But in the case of Mars, maybe that heat source disappeared, plate tectonics stopped, that feedback of carbon, which is called the carbon cycle between the crust and the atmosphere, stopped, and that might very well have been, the reason why the atmosphere changed. A lot of its water, some of it went into space, dissociating into hydrogen and oxygen. A lot of it froze on and underneath the surface. So there you are. There's the geological history of Mars in 5 minutes, made up on the spot. No, it's not. That's what scientists think.
And Fred, the other thing I was amazed with the Spirit and the Opportunity rover was all of a sudden they found meteorites on another world. And I think the first one was 2005. So one of the other things we know by the chemical analysis of a number of meteorites on the Earth, by looking at the gaseous bubbles that have been trapped inside, that they've come from Mars.
Yeah.
And in particular, we had some famous ones found in Antarctica. And there has been this suggestion that maybe the Earth was seeded by life from somewhere like Mars, where a large object has come in and struck Mars and blown material off, and that stuff carrying maybe bacteria or, as you said, amino acids that have been found in things like the Murchison meteorite could seed other worlds. What are your thoughts on that, Fred?
Yeah, it's not impossible. So we now know of it's somewhere between 200 and 300 Martian meteorites. I think it's a huge number. It's grown enormously in the last 10 years. When I wrote Why is Uranus Upside Down, which was back in 2007, there were only 30. But now it's probably 10 times that number. And these are not like the meteorites you're showing here, which are things that have landed on Mars. These are things that have been chipped off Mars by something big landing on it. And those meteorites those meteoroids, as they would be then, reaching an escape velocity of the planet Mars and eventually finding their way to Earth. And you're quite right, it was only after the Viking orbiter actually gave us insights into the actual composition of Mars's atmosphere that you could recognize that these meteorites had come from Mars. And there are 3 different categories of them. I can only remember Shergottites. Nakalites is another, and there's another one, I've forgotten what it is.
It's a Russian sounding name, I remember. Chur something rather.
Yes, that's right.
Yeah.
Anyway, those Martian meteorites seem to group, and it looks as though they have, the ones with the common name have all come from the same impact site, so something crashing into Mars. But what a free gift from the surface of another planet, a chunk of rock that you can identify positively as having come from Mars. What would be brilliant would be to get on the surface, with your geological hammer to something like the thing that you've got on the screen there, and actually have a go at it. That's a big meteorite, that particular one. But there are many that have been found on the surface of Mars, yes.
All right, so let's. Can you see the chat questions there? Okay, Fred.
Not at the moment, but I'm sure I can.
Down in the bottom right-hand corner.
Yeah, let me put this chat.
I can read some of them to you.
No, I've got them. Yeah, got them now.
So one of the questions that has come up from, and we're certainly not going to be able to get to everyone's questions, but is with the meteorite, why no crater around a meteorite? Something that large. And I would certainly.
This is the one that you've got on the
screen. Meteorite
screen.
we're looking at on Mars. And so I would comment that, it depends on the angle that the meteorite comes in, and a number of things on whether there's a crater formed, and of course, water could have moved uh, meteorites on the surface of Mars in the past, and so on. Can you comment on that, Fred?
Yeah, no, I agree with you that it's unlike the moon, which is a completely sterile environment. If something like that lands on the moon, then it stays where it landed, and the crater around it, and there will be a small one, survives. There are many, many small craters on the moon that would have come from an object that size. But Mars has it's got a dynamic atmosphere, even though its air pressure is low. Nevertheless, it's enough to fly a helicopter, and it's enough to erode rocks and soil. Plus, as you've said, we believe that Mars was once warm and wet. The whole structure of the locality could have changed. It's a great question, though. Thanks very much for
Absolutely.
answering.
I was just going through some of the comments here, and I like the comment from Kerry Doherty, the awful movies with Deadly Ernest. He was on in Sydney as well. And I know he was, played by different actors and so on. There's a few people commenting about my inverted writing. Apologies about that. We were fiddling around with that. Let's have a look what other questions here. One question is, do you think Olympus Mons would have been as large as it is now if Mars hadn't lost much of its atmosphere?
Probably, although in a sense the two processes are linked. The fact that Olympus Mons is large because it grew from a hot spot underneath the crust, and the crust never moved, so it just keeps on growing. That's the fact that the crust is solid and not broken up into tectonic plates like the Earth's is. That in itself is one of the reasons why Mars might have lost much of its atmosphere. So that's two things that might have a common cause. But I don't think, the atmosphere itself would have had much effect on the size of Olympus Mons. It's just grown like topsy because of the amount of material that was available to it under the surface.
And Daniel Riccardo makes a good comment too about craters being infilled by wind-transported regolith and dust. And of course, Mars has dust devils that have been witnessed on the surface of Mars as well. Do you want to comment about some of the atmospheric effects, Fred?
Yeah, sure. So I often show movies actually that came from Spirit back in the early 2000s of dust devils, willy willies they call them in New South Wales, blowing across the surface of Mars, these columns of dust, little whirlwinds. Except on Mars, of course, they're not little, because even though the atmosphere has this low pressure, you've also got much lower gravity. As I said, it's a third of the Earth's gravity. And so these dust devils can grow up to 8 kilometers high, which is pretty enormous. The biggest one I think I've seen here on Earth would have been about, and it's in New South Wales, about 0.5 kilometre. It was colossal. But imagine 16 times that. And the other thing is, because of the almost complete lack of moisture in the atmosphere, you get high static electricity charges. So you get little lightning flickers around the base of these things as they're whirling around, and those spirit images that I show actually show that as well. I glossed over a story yesterday, I think it was, because I didn't have time to read it, but I will go back to it. I think Curiosity has now imaged some dust devils as well.
That's great.
I have to have a look at that. Talking of dust devils, though, it's not just little columns of dust that you see. Mars can have global dust storms, and we actually had one last year. In the year before, 2018, there was in June, there was a global dust storm that kind of almost blanked out the whole planet, covered all the rovers with a thin layer of grimy looking dust. But that's an extraordinary thing. Imagine if that happened on the Earth. We get them in Western, in outback Australia generally, you would get them in South Australia, we get them in Western New South Wales. Big dust storms, but not global in size.
Yes, thanks, Fred. Sorry, I apologise if the screen's not as big as it should be. I'm struggling getting used to this technology still, with widescreen and so on. All right, so what else have we got here? Um, if life was found, what would we most likely learn? Would biological characteristics reveal precious Mars environmental, Mars environmental conditions, and what would be your ideal finding?
You know, my ideal finding would be a skull.
Exactly.
Just, yeah, just imagine that. That would set the cat among. I mean, I don't mean a human one either. I mean, you know, an alien skull. That would be really quite extraordinary. But what we're most likely to find is something that can be shown to metabolize, something that can be shown to have, you know, the mixture of proteins and DNA and all the rest of it that we're used to. So while Perseverance has been sent to try and identify whether there is past or present life on Mars, it's actually not that well equipped with the devices you need to really clinch this, you know, the yes or no of there being Martian life. But what it's doing is, or what it will do after February the 18th, when we hope it lands successfully, it will be putting together little samples of the rocks and soil of Mars in places where the mission scientists think these are very likely to be worth further investigation. These will be stashed away in little airtight containers for return by a future mission. And in fact, the planning for that mission, maybe of the order of 2026, is already in train. So we might not get answers from Perseverance, but we might get some strong hints that there was life, or maybe that there even is life on Mars. And that really will be the discovery of the century, if not the millennium, to discover that there is life beyond the Earth. What we'd really like to know, and you can only do this with genomic sequencing and things of that sort, we'd really like to know whether that life has a common origin with life on Earth, because then you're back to that situation that you and I were just talking about, Paul, of one planet seeding the other. We don't really know which way around it might have been, but maybe we're all Martians, or maybe there are traces of remnant Earth bacteria on Mars. Well, there are, because they've gone on the spacecraft. That's one of the points about the whole thing. We haven't really touched on the idea of planetary protection, the rules that have to be followed when you send a spacecraft to Mars in order to prevent earthly bacteria from taking hold on a planet Mars.
Excuse me, everyone. Yeah, one of the things I remember with one of the Apollo missions, Fred, and you'll probably remember it better than I, was they went and looked at, it was either a surveyor, I think it was one of the surveyor missions.
Surveyor 3.
And yeah, they found, was it a tardigrade or bacteria or something?
It's not, it was bacteria, that's right. So
yeah.
it was Apollo 12, and Apollo 12 landed right next to Surveyor 3, which had been on the surface for 67 to 69. It was 2.5 years, nearly 2.25 years. And so what they did was bring back a few bits and pieces to try and see what the effect of that length of time on the moon was on a mechanical and electronic structure. Of course, you've got, you know, like almost 300 degrees Celsius temperature range from nighttime to daytime on the moon. So that happens every month. You've also got the bombardment by the solar wind. You've got solar UV unabated on the moon's surface. So they brought back bits and pieces, including the TV camera that was on Surveyor 3. And when it was returned to Earth, a colony of viable microbes, it was Streptococcus Mitis. It's what's in your throat and your nasal passages. It's basically just what comes out when you sneeze. Streptococcus mitis was found, and these were living microbes which were found actually in the foam, the insulating foam of the camera. And the fact that they were found there led people to believe that this was not earthly contamination. It wasn't something that happened on the way back in the, the Apollo command module with 3 astronauts who must have sneezed at some point between the moon and the Earth. The thinking was that it was actually microbes that had been on Mars and survived, on the moon and survived on the moon. But it's still a controversial outcome, but what an extraordinary thing that this may well have happened. These microbes might have survived that long on the moon's surface.
Thanks, Fred. Someone asked me about where I got my backgrounds, just off the web. The one I've got at the moment, if you're an old sci-fi fan, you'll know it's the flight deck of the Jupiter 2 from the original Lost in Space series. So you'll find lots of these on the web that you can use in the background. One of the other questions was about is Perseverance being targeted to land at a particular place on the surface of Mars at this point?
Yeah, fantastic question, because it's not just a random place. It is a place called Jezreel Crater. It's actually not that far from the Elysium Mons system, the volcanic system that is sort of on the opposite side of the map from Olympus Mons. But it is an extraordinary place. It's a crater which has on its western side a river entry. There's basically a river channel that comes through the walls of the crater, and then a delta spreads out over the crater fall. And then on the western side, there is a gorge, which is the outflow from this crater. So it has clearly, at some time in the geological past, been a reservoir of water. It's had water flowing in, forming a delta, water going out, forming this chasm. And so Perseverance is targeted to land on the delta structure, because we know that deltas, that the water flow in delta is low, it's relatively slow, and the deltas are fantastic for deposition of silt. It's where, a river dumps its load of silt as it flows into the sea. It's in the delta. And so the thinking is that if we're going to find evidence of past life on Mars, fossilized life perhaps as microbes, that's a great place to look. And I think they've chosen well.
Yep. All right. Now, someone just said to me, I'm sharing my desktop. I was actually fiddling around trying to get Fred blown up here. Does anyone have any suggestions what button I've got to hit to get him blown back into full screen here?
No, don't worry.
A screen sharing button here, but let's have a look here. Unshare your screen. How do I do that? Let's have a look. So how do I unshare my screen?
While you're fiddling with that, can I ask a question that I've just seen?
Certainly.
It's from Peter Carty. Considering how much junk we've already dumped on Mars and the stuff the first astronauts will leave, isn't planetary protection a joke? And the answer is no, because everything that has landed on Mars to date has had to go through the rules. If you're landing a spacecraft in a place where liquid water could occur, and there are places on Mars where the temperature just gets high enough for liquid water to form, then you have to go through what's called category 4C, I think it is, sterilization, which says that the entire spacecraft can contain no more than 30 microbes. And that is almost impossible to achieve. You do it by baking it and, really quite extraordinary measures. And then it has to be sealed in a biochamber on the spacecraft. So Curiosity went through that, Perseverance went through that, Spirit and Opportunity did. It adds 10% to the cost of the mission. It's a colossal overhead, but it's worth it to try and stop microbes making the journey on our spacecraft. The other side of this, though, the first astronauts, now that's a different question, because there's no way we can sterilize astronauts. And I've asked 2 NASA luminaries, what's going to happen to the planetary protection rules when humans walk on the surface of Mars? And the answer is not that it's a joke, but almost that there will be either seriously modified or quietly forgotten. It's clear that we are entering a different regime in the way that we treat Mars when humans walk on it, which is again a serious issue, given how much care has been taken to keep Mars sterile to date. And then the first person to walk on Mars carries far more microbes than have ever gone there before. So really interesting question, which doesn't, I don't think, yet have a satisfactory answer.
All right. Yeah, I apologise for the constant clicking and working out where I am and so on. What else have we got here? Peter sort of said, well, considering how much junk we've already dumped on Mars and the stuff the first astronauts will leave, isn't planetary protection a little bit of a joke?
Yeah, that's Peter's question, which
sorry.
It's all right. No, don't worry, because Peter's asked another one, which is, aren't those rules recent while the early probes didn't care? And the answer is no. They were drawn up before, I think in 1967, at the same time as the COSPA, the Outer Space Treaty. When the legal framework for spaceflight was being set up, that's when the planetary protection rules were put in place. And of course, that predates the first landers, which were the Viking Landers in 1976. So,
Fred, on the Viking Landers in July and September of 1976, there are a number of scientists, still argue that during those missions, they think the tests they did, life was found. What are your thoughts on that?
Yeah, it's another one of these really controversial issues, because the Viking landers were designed to look for the byproducts of metabolism. I think gas emission and things of that sort. I think the idea was they cooked samples in an oven and looked at what came off. And yes, they found a positive result, and everybody said, oh, there must have been something wrong with the equipment. I don't know enough about the details of either the experiments themselves or the results to be able to comment on that. But suffice it to say that the general consensus among the astrobiological community is that they were spurious results, that we didn't find life there.
Mm. And I think the same comments were with ALH 84 or whatever, how many numbers, zeros there, one. There was a suggestion that they'd found microbial life, and then some scientists said, well, look, that DNA is kind of smaller than that. What are your thoughts on the findings there as well?
Yes, that's I think it's ALH 840001.
Yeah.
Usually just called the Allen Hills meteorite. And that's the one that, yes, on the eve of, I think it was Bill Clinton's re-election, is that right? Was claimed by various people to prove that life existed beyond the Earth, because they found structures which are highly suggestive of microbial life. I've looked at the micrograms of ALH84, etc. And, there's these little squiggly things that do look a lot like single-celled organisms on Earth, except that they're 100 times smaller. And the consensus there has long been, for 25 years, it's long been that these are formed chemically rather than by biological processes. And I might just make a comment. There's an astrobiologist who I occasionally communicate with, he's now in Italy, he was in the USA, who pointed me to some extraordinary work that's been done going back over actually almost a century. I think the first was a book published back in 1916 or something, which shows the kinds of structures that pure chemistry can create. Just, chemical reactions can produce things that you would absolutely swear were living organisms from the way they look. But they don't pass the other tests. They don't metabolize, they don't change. They are just chemical structures. And so astrobiologists are, they're very much on their guard against, well, this looks like a microbe, so it must be one.
Well, the Yuri Miller experiment was a good example of that. You know, what happens when you put all these things together in a flask and add electricity and so on.
That's yes. Yeah, well, that was producing amino acids, I think, wasn't it, or something like that, proteins. That was an experiment a long time ago. This was more about chemistry itself can look like life, but isn't. And in fact, I asked him, this scientist, I asked him specifically about some work that was done in Gusev Crater. But I beg your pardon, no, it wasn't. It was Curiosity. So it wasn't Gusev. Gusev was where Spirit was. Curiosity. Right. Okay. I'm going to backtrack there because it was actually Gusev Crater and it was Spirit that made these measurements. They identified some things called opaline silica. This is essentially a rock formation, and they looked at the structure of that on Mars and looked also at its infrared signature, the amount of radiation there is in the infrared with the spectrum. And it turned out to be virtually identical to some formations in a place called El Tatio, which is the highest geyser field in the world. I've been there, actually. It's at 4,200 meters, so you can hardly breathe. But you've got this, it's the highest it's not a geyser field, it's a geothermal field. And there are these opaline silicates there, which are known to have been formed by biological products. They're biomats. They're biological matting. And that's how they were formed. They've sort of fossilized into these opaline silicates. The Spirit mission scientists found exactly the same sort of thing on Mars, but this scientist colleague drew, he made it very clear that you need to be really careful what conclusions you draw from that. It might be consistent with it being life, but it's certainly not proof of there ever having been life. Amazing stuff. It's easy to find on the web. That was a report in Nature. Actually, it's 4 years ago now, but it's still interesting work.
And one of the things I love asking biologists and various scientists, is a virus alive? And it's life is very hard to define sometimes. And
yes.
And the last time I asked someone that, he said, well, he would say it's alive, but I mean, of course, it can be dormant as well. So there seems to be a mixture of answers that you get when you ask various scientists whether something is living or non-living. And, when we go to other worlds, if we were an alien ship landing on the Earth, would we recognize something like a stromatolite or a thrombolite as being alive? If I was walking along and looking at a stromatolite, I'd say it's a rock. I wouldn't think of it as a microbial colony, basically.
You've touched on something that we probably should have talked about earlier, because there isn't really a definition of what is a living organism. I guess the common one is a self-sustaining, self-replicating entity that is capable of Darwinian evolution. That's one. I think that one lets me out, actually. I don't think. But you talked to, like, Paul Davis over there in Phoenix, an astrobiologist, former cosmologist, but now astrobiologist. You ask him what essentially identifies a living organism, and he talks about the flow of information. It doesn't so much talk about chemistry. It talks about information, that a living organism can encode information in such a way that it can change its environment and things of that sort. And then another astrobiologist, mate of mine, Charlie Lineweaver, who you probably had him speaking at.
I know well, Charlie, yeah.
Yeah. His definition is even more broad. What does he call it? Out of equilibrium. Evolving, I can't remember the exact details, but it's the out of equilibrium bit is the key thing. It's not in sync with its surroundings. It's different from what you would expect from its surroundings. And somebody once said to him, well, the atmosphere of a star is like that. It's out of equilibrium. He didn't care about that. He said, that's fine. It might not be a living organism, but it gets people thinking about it.
Yes, definitely.
So he's always very good with challenging thoughts, is Charlie.
Vi said Charlie's a bit of a legend there. You won't get any argument from Fred and I, I'm sure.
No.
We're actually, time's gone very quick, Fred, and I think we've got time for one more question. And one of the questions is, do you think the environment at the bottom of the Valles Marineris would be significantly better in terms of air pressure to prompt life?
Well, it's certainly going to have slightly higher pressure. It won't be that much higher, but yes, it will. And the conditions down there. I mean, when you think of the Grand Canyon, which is much less impressive than Valles Marineris, the conditions at the bottom, just incomparable with what's at the top. So I suspect something like that will be the case on Mars too, but not with as much differentiation. You're not going to have snow on top and none on the bottom, although there will be times when there might be frost on top and none underneath. So, and again, it's, for all it's on the equator, so it will get direct sunlight at all times. You're never going to have places that are always shaded from sunlight. There will be places that during the solstices are shadier than others, and that might have an influence on the origin of life there, or the existence of life. Really interesting stuff. Wouldn't it be wonderful to take a trip down Valles Marineris?
Mars is, just one of those worlds we could talk about probably for hours and hours. It's a fascinating world, as are the other worlds in our solar system. We could probably spend months discussing, places like Enceladus and Europa, and the possibility of life on other worlds like those. Ladies and gentlemen, thank you for all of your comments. I'm sorry we didn't get to them all. I like Adam Joyce's comment there. Make sure any probes wear a face mask.
Yes,
it's particularly valid at the moment. Thank you for your kind comments, for coming along and listening, everyone. I'm very happy to see someone knitting there as well. Lydia, you're knitting there. I hope you're knitting something astronomical there. I'm sure you'd have a few orders if that were the case. But ladies and gentlemen, would you please firstly thank Rona Sacco, who's probably somewhere on the side there with us, for organising this as part of National Science Week. Thank you, Rona. I'm sure if you're interested in events like this, again, you can chat to Rona. You can certainly email me if you've got any queries about lectures. Of course, I'm based in Adelaide, so most of the stuff I do is in Adelaide. My email address is easy to remember. It's starmanzone, all one word, at adam.com.au. I've got a few educational videos on there. You can have a look. If you look up Starman's 2-Minute Astronomy, if you've got kids and people that want to learn a little bit about astronomy, we're slowly trying to put up a few videos there as well. But I'm sure you'll all agree that Fred is an amazing communicator. I'm not saying that just because Fred's become a friend over the years. I remember the very first time I met Fred, very personal fellow. He has the unique ability to, well, not unique, but rare ability to be able to put very complex subjects in lay terms. And that's very important to be able to do that. It's a skill, Fred, and you do that very, very well. So you've got your little reaction buttons down there. Please give Fred a bit of a clap. And ladies and gentlemen, we'll bring this to an end. And thank you again, Fred.
Thank you, Paul. Thanks for fixing it up. Thanks for all the smooth IT. It's gone really well. And thank you everybody for joining in. Seeing 105 of you on the screen there has been it's done me a power of good. Thanks. It's made my cup of tea good really well. Thanks again. Bye.
Rest up, everyone, now, and think of the red planet and the universe beyond.
Exactly.
Thank you, everyone. See you, Fred. Thank you again.
People, no worries. See you next time. Bye-bye.
Bye. Bye, everyone.
Bye, Hans.